All right, so we classified polygons. Now we're going to talk more specifically about angles inside and outside of polygons. There's a formula that you're going to have to remember. It is to find the sum of the measures of the angles on the interior of a convex ingon or convex polygon. And that formula that you're going to be required to remember, this is not on the star chart, is n minus 2 times 180. And remember, n stands for the number of sides of the polygon. So n minus 2 times 180. So what happens is when you add the measure of angle 1, 2, so forth and so on. So all of these angles inside of here, you take the number of sides, you subtract that by 2, you times it 180, and it's going to give you the measure of the interior angle. So you can see here we have 6. So if I did 6 minus 2, that would give me 4. Then 4 times 180. And so when you do 4 times 180, it's going to give you the measure of all the interior angles, which is 720. So what this is saying is if we actually measured 1, 2, 3, 4, 5, and 6, all of those angles, and added everything up, the total would be 720 degrees. Now, also what we need to know is that inside every quadrilateral is 360 degrees. So that's just something that's easy to remember, so you don't have to do the n minus 2 times 180, that all quadrilaterals are 360 degrees. So let's do some examples. We're going to find the sum of the measures of the interior angles of the indicated convex polygon. So a hexagon, so here, you're going to be given this word, and you're going to be responsible for knowing how many sides that is. So remember, you're going to have to know triangle, rectangle, pentagon, hexagon, heptagon, so forth and so on. So a hexagon has 6 sides, so we're going to do n minus 2, which we just did in that example, times 180. So 6 minus 2 is 4. 4 times 180 is 720 degrees. All right, for a 20gon, so n is equal to 20, so we're going to do 20 minus 2, which we have to do first, so that's 18, and then we have to times that by 180, so make sure you're doing the subtraction first. So this is 3,240 degrees is on the inside of a 20gon. Next, we're given a picture. We're going to have to count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. So let's just go ahead and get used to the name. It's an octagon, so the number of sides is 8. If we do n minus 2 times 180, which is 6 times 180, that gives us a total of 1,080 degrees on the inside of every convex octagon. Now this is kind of working backwards. It's saying, all right, here are the sum. They already did the n minus 2 times 180. And this is what they came up with. These are the sums. Now they want us to classify by the number of sides. So remember, classify is the fancy word. So you're going to have to know hexagon, heptagon, so forth and so on. So you're going to have to work this backwards. So they took the formula, n minus 2, they times it by 180, and they got 540. So this time when you work backwards, we've got to solve for n. So what happens is this 180 has to get multiplied by both of the things inside the parentheses. So this is 180n minus 360 when you distribute that 180 to both those pieces equals 540. Now it's just like solving an equation. We're going to solve for n. So we're going to add 360 to each side. So 180n is equal to, we're going to add those together, so 540 and 360 gives us 900. Then we're going to divide by 180. So 900 divided by 180 gives us 5. So if we have a 5-sided polygon, what is that called? You're right, it is called a pentagon. So the answer to number 4 is pentagon. All right, so here in number 5, we get 900 degrees, so we're going to work this backwards. So n minus 2 times 180 is equal to 900. We're going to distribute that 180, so that gives us 180n minus 360 is equal to 900. Add 360 to each side. So 180n is equal to 1260. Now we're going to divide 1260, divide by 180, and we're going to get 7. So a 7-sided convex polygon is called a heptagon. Now, if you're listening, your thing for you to do is to finish number 6, and I'll be looking for number 6 worked out and the answer, classify the polygon by the number of sides. So you're working number 6 if you're listening on your own. You will show it to me tomorrow and we'll check it. All right, let's go on to number 7. This is saying, all right, if each interior angle of a regular polygon has a measure of 162. So this word each is super important. So each one is 162 degrees. They want to know how many sides does the polygon have. So basically they're telling you, like if we were just to look at this for an example, they're measuring that each one of these on the inside is 162 degrees. So basically what happened? N minus 2 times 180 is going to give you the sum of all of the interior angles. Well, if we take that sum and we divide it by n, the number of sides, that's going to give us the measure of just one of the angles. So in this question, they did that. They took the sum, they divided it by the number of sides, so they could just get the measure of one angle. And when they did that, they came out with 162. We got to solve this. Remember the first step, if you're looking at an equation with a fraction, that you need to clear out your fraction by multiplying by the denominator. So we're going to multiply this side by n, and we're going to multiply that side by n. Those n's are going to cancel out. So the equation that we're left with is n minus 2 times 180 is equal to 162n. Now see, that doesn't look that bad. That's really, really doable. So let's see, distribute here like we've been doing before. 180n minus 360 is equal to 162n. Keep solving. Subtract 180. So we have minus 360 is equal to, and we're going to subtract that out. So 180 minus 162 is going to give us to 18. So this should be negative 18, so we're dividing by negative 18. So 360 divided by 18 is going to give us 20. So this polygon has 20 sides, so it is actually a 20-gon. So 20 sides, it's a 20-gon. All right, now we're going to find the value of x. So here we go again. Remember, you're an equation creator. These, though, are a couple of steps, because to solve for x here, we're going to have to add all of these up. So if we go, all right, 105 plus 88 plus 142 plus 140 plus 124 plus x equals, well, we don't know how much all of that should equal because we haven't done n minus 2 times 180. So we've got to do that first. So we've got to count 1, 2, 3, 4, 5, 6. Well, if it has 6 sides, if I subtract 2 and times that 180, I get 720. So that is what I set all of this equal to. So now I'm going to combine all of that together. 105. Plus 88 plus 142 plus 140, 124 gives me 599 plus x is 720. Subtract 599 from each side. So 720 minus 599, you're going to get 121. So here, your x is equal to 121, and that's actually an angle, so it's 121 degrees. So again, when we solve for x, remember x means an equation. we needed a sum. So we had to add everything up on the inside to some number. Well, we actually were responsible for finding that number first ourselves, so then we could set it equal to. How about you pause it and try number 8, and then come back and check and see how you did. All right, so in number 8, if we got to make an equation, so we're going to say, all right, I know I've got to add 86 plus 110 plus 64 plus 3x plus 2x, but I don't know what to set it equal to. I've got to find that out first. So 1, 2, 3, 4, 5 sides. So if we go n minus 2 times 180, so that's 5 minus 2. So 3 times 180 is going to give you 540. So now you know how much to set all of this stuff equal to. Combine your like terms. So 86 plus 110 plus 64, 260, 2x, 3x, keep solving. So 540 minus 260 gives you 280. If you divide that by 5, you're going to get 56. There you go. Hopefully you did a good job. All right. On the outside is so much easier. All you have to remember is that the sum of the measures of the exterior angles of a convex polygon, okay, of one angle is 360 degrees. So everything on the outside, no matter how many sides it has, is 360 degrees. Bam, that's it. So we're going to say, all right, we've got to add all of those up. So 93 plus 75 plus x plus 2x. If those x's are on the exterior, that sum that is 360 every stinking time. So 93 plus 75, 168. Combine those, that's 3x. 360 minus 168. So 3x is equal to 192. If you divide that by 3, x is 64. So try number 10 on your own. Pause it and then come back. You can do it. All right, in 10, we notice that the x's lie on the exterior of the polygon, so we're going to add all those up. 4, 5, 6, 7. And this is 90 plus 60 is 150. Everything on the exterior of every single polygon is equal to 360. So 360 minus 150 gives us 210. If we divide that by 7, lo and behold, 30. All right, so let's check out number 11. What is the measure of each exterior angle of a regular nonagon? Oh, bunch of stuff we've got to remember in there. Each means just one, right? Just one. Regular means all the sides are the same. And then we also have to remember nonagon means the number of sides. So again, by test time, you've got to... All right, well, since all exterior angles of any polygon add up to 360 degrees, if we take the total and we divide it by the number of sides, that's going to give us the measure of just one angle. So here we would take 360 and divide it by 9. 360 divided by 9 is 40. So the measure of one angle is 40 degrees. Last one. The measures of the exterior angles of a convex quadrilateral are 90, 10x, 5x, and 45. What is the measure of the largest exterior angle? All right, so we have a quadrilateral, and it's telling us that all of these exterior angles, all right, one is 90 degrees, one is 10x, one is 5x, and one is 45. And again, I just sketched this. It's not really drawn to scale because obviously it doesn't tell us that all of them are the same. However, we know everything on the exterior of any polygon should add up to 360. So I'm going to put all of these together, set them equal to 360. Let's combine like terms. Set it equal to 360. Subtract from 135. If you're still listening, let's go ahead and draw a house inside of your quadrilateral on number 12 so that I can ensure that you're listening and doing a very good job at listening. So draw a house inside of your quadrilateral on number 12. So 225 divided by 5 is 45. So that's the measure of x. The question asks, what is the measure of the largest exterior angle? So we have to take this and plug it back in. If we have 10 times 45, well, that doesn't make any sense, Ms. Poliak. Oh, I should have been dividing by 15, not by 5. 225 divided by 15 is 15. All right, there we go. I caught my mistake. I knew that angle couldn't be 450 degrees. So your x is 15, plug that back in. So this one becomes 150 degrees. If we have 5 times 15, this one is 75 degrees, and we already have 90 and 45. So the answer to our question is 150 degrees.